This lecture explains the use of the keyboard and reshape callbacks. Glut keyboard func allows us to specify a keyboard callback function, and we can choose any name for our keyboard callback function. The next thing is that we must define a callback function that should be executed when a keyboard event happens. The keyboard event is of course the pressing of a key, but not only does the keyboard callback function needs the key which is pressed, it also takes in the location of the mouse at the time when the key was pressed. Here we have defined the full function. The function does not return any value. It takes in the char value of the key that is pressed and the XY location of the mouse when the key was pressed. Here we are simply exiting our program when the key Q is pressed. And we're giving both options with an OR in between. So whether a lowercase q is pressed or an uppercase q is pressed, the program must exit. In addition to the alphabets and the numbers, our keyboards also have special keys and modifier keys. These keys are also defined in glut.h. For example, the function key with F1 is defined as glut underscore key underscore F1, and the up arrow key is defined with a key underscore up. And if you want to detect, for example, the function key F1, we will say if key is equal to, which is the double equal to sign, glut underscore key underscore F1, and then specify what should happen. We can also detect one of the modifier keys, such as the shift with the glut active shift, the control, or the alt key. And we can use the glut get modifiers to find out whether one of these keys are active or not. This allows us to emulate 3-button mouse with 1 or 2 button mice. We can reshape and resize the Opengl display window by pulling the corner of the window. What happens when we perform this action? What happens to the display? The window in the application must be redrawn. There are 3 possibilities when we perform this action. The first possibility is that we can display the whole world but force it to fit the new window. However, this can alter the aspect ratio of our world. The second option is that we can display part of the world and skip the other part. The third and the most desirable option is that we can scale the whole world to fit in the new window while keeping the aspect ratio the same, and then display it. This slide graphically shows the 3 possibilities of reshaping a window. Here we have pulled this corner up and stretched it to the side so that the window looks like this. And by default, Opengl would resize the object so that it fits the new window, and in this case it will squash it. The second option is that we can write a callback function that would skip half of the world and only display part of the world so that the aspect ratio resembles the original object. The third option is that we can resize our object so it still fits the window and keeps the aspect ratio of the original object but not the size of the original object. Let us look at how to specify a reshape callback function. We use the glut reshape func command to specify a name for the display callback function. Following this, we must also specify and write or complete my reshape function that will be executed every time the window is reshaped. The parameters passed to this reshape function are the width of the window and the height of the window. So these are the width and the heights of the new window, and it is up to us what we use these parameters for. So what happens is that when the window is resized, a display is posted automatically at the end of the execution of the callback. Now glut has a default reshape callback function that would squash all the objects so that they still fit the window. But probably we want to write our own to have more control on how the objects should be displayed. And most of the time it is the third option that we are after. The reshape callback is also a good place to put all viewing functions because it is invoked whenever the window is first opened and whenever the window is reshaped. Let us look at an example usage of the reshape callback function. Suppose that our original window size was 500 by 500 and our clipping volume was -2 to 0.2 to 0.2 from left to right, -0.2 to 0.2 from bottom to top, and 2.0 to 20.0 from near to far. So what does the following reshape function, callback function, do? It takes the new width and height of the window, passes them exactly like that to our GL viewport so that it still occupies the complete window, and then calls the GL ortho function and redefines the left and right clipping volumes. And here it is multiplying the -0.2 with the new aspect ratio of the window, which is width to height, and it is converting the integer values of the width and height to floats first before it performs the division. And the same goes for the right side clipping plane. The bottom, top, and near far planes are left exactly as they are. And also notice that it is not calling the post redisplay function because it is automatically called whenever the window is reshaped. Now, with the same settings as the previous slide, what will this reshape function do? This reshape function basically checks if the new width of the window is greater than the height of the window, and if this is true, it will redefine the left and right clipping planes. Otherwise, if the height is equal to the width, or if the height is greater than the width, it will redefine the bottom and top clipping planes of the viewing volume. And the end effect would be the same. It just simply ensures that the maximum of the width or height is kept as a reference point for reshaping the object size or the viewing volume so that the objects would appear with the same aspect ratio as they were originally defined.